Matter feels like the obvious foundation of reality. You touch it, weigh it, break it apart, and watch it interact. From everyday experience, the universe looks like a vast collection of things made of stuff, moving through space, obeying forces. Computation, by contrast, feels artificial. Something humans invented, a process that runs on machines we built, not something that could underlie the cosmos itself. And yet, physics has been drifting toward a deeply unsettling idea. Matter may not be the base layer of reality at all. The universe may be running on computation, not metaphorically, not as a simulation created by someone else, but as a physical process where reality updates itself according to rules, much like a computation does. This idea did not come from computer science invading physics. It came from physics running out of other explanations. Again and again, when physicists tried to describe what reality is made of, they found not solid substances, but processes, rules, and information flows. Particles dissolved into fields, fields dissolved into excitations, excitations dissolved into probabilities. At the deepest level, physics stopped talking about things and started talking about state updates. The universe at every moment seems to take a state and transform it into another state according to precise rules. That is exactly what computation is. This realization becomes unavoidable when you look at quantum mechanics. In quantum theory, the state of a system encodes all that can be known about it. The wave function is not a picture of particles moving through space. It is an object that evolves according to an equation. That equation takes the current state and computes the next one. Measurement does not reveal a hidden value. It forces a transition, a state update. The language of computation fits this structure uncomfortably well. Reality does not flow, it updates. The same pattern appears in quantum field theory. Fields evolve. Interactions are rule-governed transformations of states. Even space-time, when treated quantum mechanically, resists being described as a static container. Many approaches suggest space-time itself is a network of relations that update. Geometry becomes dynamic. Distances change. Connections rewire. The universe behaves less like a stage and more like a process that continually recalculates itself. This does not mean the universe is a computer in the everyday sense. There is no external hardware, no memory chips, no clock ticking outside the system. Computation here means something more abstract, a system evolving through discrete or continuous state changes according to consistent rules. The universe does not compute because it was designed to. It computes because that is what physical evolution is. Every physical law is an update rule. Every interaction is a local computation. This view gains strength when you consider limits. Physics places strict limits on how much information can be stored in a region of space, how fast it can be processed, and how much energy is required. Black holes saturate these limits. They behave like maximal information processors. The laws that govern them resemble bounds from computation theory. The universe respects constraints that look suspiciously like computational constraints, not because it runs on silicon, but because information processing appears to be fundamental. Matter, then, becomes a way computation looks from the inside. Stable patterns of information that persist across updates appear as particles. Long-lived processes appear as objects. Repeating update rules appear as laws. You do not experience computation directly. You experience its output. Just as you do not see transistors switching when you watch a video, you do not see state updates when you perceive a table. You see the rendered result. This perspective also clarifies why physics is so mathematical. Mathematics describes transformations, mappings, and relations. That is exactly what computation consists of. If reality is computation, mathematics is not just a descriptive language. It is the logic of the process itself. Equations do not merely approximate reality. They specify how updates occur. When mathematics predicts new phenomena, it is not guessing. It is following the rules of the computation deeper than observation has reached. This helps explain why matter feels secondary. Matter is not the driver, it is the pattern. It is what stable computation looks like when rendered in spacetime. Destroy the pattern, and matter disappears. Preserve the pattern, and matter persists, even if the underlying components change. This is why identity survives atomic turnover. Your atoms change. The computation that maintains your structure continues. You are not the stuff. You are the process. This idea becomes more disturbing when you realize that computation does not care about meaning. A computation runs whether or not anyone understands it. The universe does not need observers to compute. It updates regardless. Observation is just another computation interacting with others. Consciousness itself may be a high-level process emerging from layers of simpler updates. This does not reduce experience to something trivial. it reframes it. Experience becomes something that happens inside the computation, not something outside it looking in. One objection immediately arises. Computation, as we know it, requires discrete steps, but physics often appears continuous. Space looks smooth, time looks continuous. How can a continuous universe be computational? Physics has an answer. Continuity may be an approximation. At small scales, space-time may be discrete. Even if it is not, computation does not require discreteness in the everyday sense. Analog computation exists. Continuous systems can compute. What matters is not discreteness, but rule-based state evolution. And physics is nothing if not rule-based. Another objection is more philosophical. If the universe is computation, what is it computing? This question assumes computation needs a goal, but computation does not require purpose. A system can compute its own next state without aiming at anything. The universe computes because it must be consistent with itself. The next state follows from the current one. No intention required. This perspective also dissolves some old puzzles. The arrow of time becomes the direction of computation. Entropy increase becomes information dispersal across states. Causality becomes dependency between updates. Free will becomes a process embedded in the computation, not something external to it. None of this makes life meaningless. It makes meaning local. Meaning arises inside the computation, not outside it. The universe does not care about purpose. Processes inside it do. This is why the idea feels cold. It removes the sense that reality is built around things like matter, substance, or essence. It replaces them with process, rule, and update. But physics has been moving this way for a century. Every step has removed another layer of substance. What remains is structure, constraint, computation. This does not imply that the universe is fake or simulated. It implies that matter may be an emergent description of something more abstract. The universe might be closer to a calculation than a machine, and you live inside that calculation as one of its self-referential processes. The unsettling part is not that reality might be computation. It is that computation does not need solidity, flow, or substance to exist. It needs only consistency. And consistency is exactly what physics keeps finding. The universe updates itself relentlessly, moment by moment, state by state. It does not pause, it does not reflect, it computes. And everything you call real is a stable pattern within that ongoing process. Matter is what computation looks like from the inside. The universe might not be made of stuff at all. It might be made of rules running on themselves. This is Veritas Labs, where truth is tested.